Hi everyone, we're graphing polynomials today. So we're using this with, I'm using Desmo, so you can use the yellow calculators, but same thing. So I'm going to put in parentheses the 1/2 so that I can have this part here. Sorry, that 1/2 I want to put in parentheses. And then I'm going to open new parentheses and put x to the power of 4 minus 9x squared plus 4x plus 12. And I should see this W shape pop up. And I can kind of mess with it here, see it, but it should be in general, looks like this. And on Desmos, if you want to find the table, you're going to go ahead and press the little gear button, and then press the table button. And it's going to show a table just like this. You can also just click, see if I can get it now. You can also just click on the points. And they will show up for you. So I can see here like all these funky little points here. So -2, -8 looks like a pretty close one. And then -1, 0, 6, -6, 0, 1, 4, and then 2, 0. And then like it just straight up goes off the graph. So I can see like up here, there are like not really any more points until I get like up this direction. So I can see that it kind of just like goes off the graph. So I put like a low key point up here. And then the same thing on this side. Let's see, that's -3, 0. And then it just kind of goes off the graph. So I can see that it kind of goes like this. My goal for all my artists out there is that we make it look like as close as possible to what we see on our screen. So that's the ultimate goal. And you can kind of like round it out if you're not such a good drawer like me. I'm like not that awesome. So I kind of like trace over it a little bit, and it helps to like make it look a little better. Because remember, we don't want any like straight or pointy parts. So that's kind of what it looks like right here. And we can see that it's x to the 4th. We know that this is called a quartic. Right? And we can see that it has 1, 2, 3, 4 terms. So that's going to be a polynomial in this case. Right, polynomial. My degree, remember, is my biggest exponent, in this case 4, which is an even number. And what it means to be even means that it's both going to be either opens up or opens down. So heads out in the same direction. Heads out in the same direction. So I'm talking about like at the end of the graph, like this part here. We can see that it's going in the same direction to end. And we see that it's going up because this graph is positive. So the 1/2 there, the 1/2 is positive, and that means that the graph is going to be going up. So I can start to like figure out what those look like without really using my calculator. For now, we're just trying to plot like the really important points here. So that's my first one. We can go ahead and do the second one. We might notice that there's something like a little different here. It's not in standard form. This is called factored form. And in factored form, we need to figure out like how many or what degree this is. So if you can imagine, like I'm doing this part and I use the box. And you can probably imagine that I'm going to get up to like x squared plus, or actually in this case, minus 2x plus 1. And then I'm still going to have to multiply times this here. And I could use the box and I could say, okay, like x minus 3 times x squared minus 2x plus 1. I don't really care that much about what happens at the end of the box, because what I care about is what happens here. X to the 3rd is going to be my biggest thing once I multiply those together. So that means that my graph should look like an x to the 3rd graph, right? It should go up like this or like that. The other way that I could tell, rather than doing all of that like box method and stuff, is that I could see here that this 2 means that there are 2 of these things. So I have x minus 1 times x minus 1 and then I have this x minus 3. And I can see if I multiplied them, I'd have x times x times x. X times x times x is x to the third. So I know that that's like the graph that I'm going to end up with. So I'm going to click back to the decimals or your yellow calculator. You don't need to like change them to anything fancy or do the box method. Your calculator is actually fancy enough to do it for you. And then I'm just going to type the x minus 3, just like that. And I can see that we were right. We have the cubic format here. So I'm going to turn on all these little points here so that I can graph them. So I see 0, negative 3. So 0, negative 3, and 1, 0. And then it kind of goes down. I can see, like, I think there's probably a point, like, somewhere close to that minimum. But it's going to be, like, somewhere at 2.3, somewhere, like, right about here. And then super important that I get my root there. And then I think there's one, like, 410 maybe. Right, like it's kind of hard to tell, but I can see that it's going off the graph. So I'm going to go up here like that. It kind of comes down. I'm going to use that same power. And I go straight down, just like that. So I'm going to kind of round it out that way. So you can see if I kind of like trace it a couple times, it looks better than if I just like kind of make this gross little line. So I can see my cubic format. I know that this is a cubic. And has many parts, so it is a polynomial. In this case, my degree is 3, because it's x to the third, which is an odd number. And since that's an odd number, it means that one's going up and one's going down. So they're going in separate directions. Right? And in this case, I can also see that this one is also positive. There is not a negative in front here, so it's a positive, which means that it's going up. Just like our last one was going up, we can see that in this graph, it's going up this way, and this one starts in the opposite direction. So we can see, like, that's pretty much it, y'all. It's like an art project a little bit here, so that is there. We also have, I'm going to drag this over. Let's see, maybe if I can do this. There we go. I also want you to like be able to tell which direction each one goes without really needing it. It's something we call end behavior. And we use the degree. So if I know that it's like x squared or x to the 4th, my even degrees, x to the 6th or x to the 10th or 12th or 20th, and I know that it's positive. So let's say it's like 2x to the 3rd. I'm sorry, 2x squared. Then I know that they're going to be headed in the up direction, and they're going to be going the same direction. So, like, I know for sure this is going up like this. I don't really know what's going to happen in here. Like, it could do something crazy, like that, or it could be just, like, really boring and go like that. No matter what is happening down here, I know that it's for sure going to go up. And the same is true for the negatives. If I have like negative 2x squared or like negative 1/2 x to the 4th or like even like negative 1000 x to the 6th, right? I know that it's going to be headed down. They're going to be going in the same direction. So no matter what, they're going in the same direction. And again, like we don't know what happens up here, right? That's for like other parts of the equation. But the beginning of the equation talks to us about what direction they're going. So it could be really boring too, something like that. Cool. So then the odds are the ones that are like opposite of each other. It's like x to the 5th or x to the 7th. And we know that if it's positive, it's going to be headed in the positive direction, like this. So you can see that it's going up, and then this one's going down. I draw that arrow on there, like that. And then for the negative odds, we are headed down like that. So that would mean we're going up this direction. Yeah, so that's pretty much it, y'all. Talk to me soon. Okay, bye.